All right, welcome to The Explainer. Today we're tackling something huge, the very foundation of how we reason. We're going to dive into Carveth Read's classic text, Logic, and figure out, how to actually build an argument that holds up.
So let's kick things off with a big question, one that really gets to the heart of all this. What makes an argument good? Is it just about having a perfect, flawless structure, or is it about being connected to reality, to what's actually true? You might be surprised, but the answer is a little bit of both.
Okay, so to even start answering that, we've got to get a handle on what logic even is. And really, at its core, it's the science of proof. It's basically the toolkit we all use to figure out if an argument is solid or if it's full of holes. And believe me, this isn't just some dusty thing for philosophers. We use it every single day.
Carveth Read said it best. A logical argument is really the most powerful way to persuade somebody. Because you're not just tugging at their heartstrings, right? You're actually convincing their judgment. It's all about building a case that's just solid. So the real question is, how do we actually do that?
All right, let's start with the big one, the one everyone's heard of, deduction. The best way to think about deductive logic is like a perfect machine. Seriously, you feed in the starting materials, you turn the crank, and boom, it spits out a result that is absolutely 100% guaranteed.
And the engine at the heart of this machine? It's a tool that's been around forever called the syllogism. It's a super simple three-part recipe. You take two things you already know are true, we call those premises, and you use them to cook up a conclusion that's brand new.
It's super straightforward. Step 1, you start with a big, general statement. For example, all authors are vain. Okay? Step 2, you introduce a specific example that fits that rule, like Cicero is an author. And then step 3, the machine just spits out the logical result. Therefore, Cicero must be vain. See? Simple.
Now, what's really cool is that this whole system, this whole machine, is built using just 4 basic types of sentences. You can see them here. They cover everything you'd need to say. All of something is this, some of it is this, none of it is this. It's like the 4 basic building blocks for any logical argument.
So here's the key takeaway, the most important part about deduction. That machine guarantees consistency if, and that's a big if the stuff you put into it is true, the conclusion has to be true. No way around it. The logic is perfect. But what if the stuff you're putting in isn't so perfect?
Because that's where we run into a problem. What happens when we feed this perfect, flawless machine faulty parts, right? What happens when perfect logic is built on a really shaky foundation?
Okay, let's look at this argument right from the book. All empires decay, Britain is an empire, therefore Britain will decay. Now, if you look at the structure, it's a perfect syllogism. It's built exactly like the Cicero one. Major premise, minor premise, conclusion. The machine itself is humming along perfectly.
The logic is totally valid. The structure is flawless. And yet, something feels a little off, doesn't it? That conclusion feels more like a prediction, maybe even a guess, not a hard fact. It just doesn't feel as certain as the Cicero one. So what's going on? Well, the problem isn't the machine, it's the ingredients we're putting in. The whole thing, the entire argument, rests on that one big idea: all empires decay. But wait a second, how do we know that? For sure. Have we studied every single empire that has ever existed or ever will exist? No, of course not. So that first premise, it isn't a fact. It's an assumption.
And that right there shows you the big limitation of deduction. It's great for consistency, but it can't tell you if your starting point is true. For that, you need a whole different kind of logic. You need a toolkit for actually testing ideas against the real world. And that, my friends, is called induction.
And this is the perfect way to see the difference. Deduction, that's our machine. It starts with a big rule and works its way down. It's all about consistency. Induction, on the other hand, is like a detective. It starts with specific clues from the real world and tries to build its way up to a general conclusion. It's all about evidence.
One of the coolest tools in the detective's toolkit is something called the method of difference. It's actually a really clever and simple way to figure out what causes what. All you do is find 2 situations that are exactly the same in every single way, except for one thing. Then you just check if that one difference changes the outcome.
So check this out. Let's say in one case, we have factors A, B, and C, and that gives us result P. Now in the next case, we do the exact same thing, but we take away factor A. So we just have B and C,
and suddenly result P is gone. Well, what was the only thing that changed? It was A, so we can be pretty confident that A is the cause of P. It's basically the logic behind every scientific experiment.
So, okay, we've got deduction, the perfect logic machine, and we've got induction, the real-world detective. So which one is better? Well, that's the wrong question. It's not a competition. The secret to a truly powerful argument, a sound argument, is that you need both of them. They have to work together as a team.
And here's how that partnership works. You use induction, the detective work, to go out into the world and gather clues, to gather evidence. That's how you build premises that are actually grounded in reality. Then you take those strong, true-ish premises and you feed them into your perfect deductive machine. What comes out is a conclusion that isn't just logically valid, it's also very likely to be true.
The book puts it perfectly. They are two parts of the same science of proof. Think about it. A perfect deductive argument with false premises? It's just a pointless logic game. And a bunch of true observations without any logical structure? That's just a confusing mess. You absolutely need both to build an argument that is what we call sound.
So I'll leave you with this final thought. Now you know the crucial difference between an argument that's just valid in its structure and one that's actually sound because it's based on truth. Start listening for it. I mean, really listen to the arguments you hear every day. You're going to start seeing it everywhere. Perfect, beautiful machines of logic running on completely faulty, untested parts.